Hello. Today we'll be looking up a little about determinants. Here we'll be looking up what actually a determinant is, from where it has been derived. Then we will talk about a special property of determinants which actually helps us a lot in many sums when the position in a sum becomes a lot tricky. Then further we'll also be looking up the expansion of a determinant pretty quickly, because there is a detailed lecture which is linked with the expansion of a determinant, which you should see in detail later. Now here first, starting off with something about a determinant that probably is pretty obscure. That is, determinant was first found out by a Japanese mathematician by the name Seki Takakazu. Now further, there has been a lot of study which has been made by Gottfried. Then it has been another mathematician by the name of Kramer. And then further, there are many mathematicians who did a lot of research on determinants, and it has been pretty helpful, especially in the solving of linear equations. Now, when we talk about determinants, we actually write it to be a square array of numbers. For that matter, if you talk about a determinant actually looks like there are two parallel lines, and in between those parallel lines you actually write the array of numbers. And like I said, as it is square, so it has the same number of rows and columns. So if we try writing one determinant, it can be, say, something like A, B, C. Then say we can have P, Q, R, and after that let's say we have X, Y, Z. So this can be any determinant of order 3. Now a determinant has been derived from a matrix. Obviously, as you know that in a matrix the order can vary. That means the number of rows and the number of columns can vary. So when a matrix is square, that means it has an equal number of rows and columns. From that matrix we can derive a determinant. For that matter, if say there be a matrix A, then of that matrix A you can find out the determinant of the matrix A. Right? In times to come we will be studying about the Martin's rule, where we get to see that this actually gets applied. Now to talk about the property for which I actually want to discuss today, now I want you people to write along with me, and that will help you to understand much more. Right? So please get ready and write along with me. First, I will orally tell you this, and then after that I'll be writing it for you people, and I also want you people to write along with me, and do be vouched, do be in guarantee that you'll be learning much more when you write once, because it then sits very well in your brain and gets assimilated, and then you can remember it for a longer duration of time. Well, what is this property? Now the property is this, that if suppose we have this determinant, then say if we talk about to any column or row of a determinant, if we add the equimultiples, like for that matter here at the moment we are talking about this column, if we add the equimultiples of some other column, then the value of the determinant, if it came out to be, say, some 4, then later also after application of this property will remain to be the same. Well, you might be thinking that applying this property is actually going to complicate things. No, it is not like that. It actually is going to help us in simplifying. For that matter, as you know, in the garb of saying addition, we can even do multiplication with a negative number so that we can subtract. For that matter, I will just quickly give you an idea. Let's say if you want to talk about 4, to which if you add -3, actually what are you doing is you are writing 4 minus 3. So if say a column be multiplied with -3 and then be added to the elements of some other column, then obviously it's going to be simplified. Right? So all of this we're going to look up here. Now at this moment, like I told you people, I want you people to be please writing this along with me, and I can assure you you will be learning much more. So if to any row or column of a determinant be added the equimultiples. That means the multiples are going to be such that if it is -2 which is getting multiplied with each and every element of the column, that will happen for every element. Equimultiples of any other row or column, any other row or column, which I'm abbreviating to be capital R or capital C, then the value of the determinant, which we normally write to be capital D, right, will remain what? Unchanged, right? So here, children, as it is going to become unchanged, so I'll change the color and write it more permanently unchanged, right? So children, I'll quickly discuss this so that you have an idea about what this means by words. Then obviously I will explain to you this with the help of an example. Now, if to any row or to any column of a determinant, right? So let's say we now talk about a row, and to it, if we want to add the equimultiples, right? Like suppose the elements of row 2 to be multiplied by 2, right? And then if we talk about the determinant, the value of the determinant, if earlier it was say some -14, later also it will remain to be -14, and this won't change. Now there is a reason which can be given with the help of the properties, but obviously that property has yet not been discussed, so it'll be futile. Well, what I'm going to do is I will give you an example where you'll be able to understand this for sure. So let us now consider that we have a determinant. For that matter, I'll rather make this to be a question, right? So please, along with me in your copies, write this question down. Find the value of the determinant. So here I'm going to give you a determinant, and I'd like you to find out the value of it. And as you can easily understand, here it can be done with ease applying this property. So here now, children, we're going to write some values, and let's say here we have the elements to be such that they are, say, some 10, 20, 30. Then we have 3, 4, 5. Then let's say we have -1, 0, and 1, right? So this, children, is the determinant whose value now has to be found out. And initially I'll give you people a little time for trial, right? Let's say some 10 seconds, and in it you should be able to crack it, because this is a pretty simple sum. If not, you can take more time by pausing the lecture. Moreover, trying is something which is very important, because that is where you learn whether you actually can do it or not. Doesn't matter if you can't do it, then when the solution is there before you, and especially a teacher who is teaching you how to go about with the sum, and you look it up, then obviously you understand more with the insights, and moreover you also remember that for a longer duration of time. So here, children, I'll be giving you at this time some time, so let's say it'd be 10 seconds. So make sure, children, that you are seated at a place where you are all by yourself, so that there is no disturbance caused by your cousins, your acquaintances, some people who really like you, or probably say you have some electronic gadgets which are disturbing you. So you have to be wary of these things, and you've got to keep it away during studies. And also make sure to sit on a table and chair, because that is what easily makes you to sit straight and thus focus better. Now children, so we have the sum and we've been given this determinant and we have to find out the value of this determinant. So let's see what is something special that we can do so that we can actually calculate this determinant with the help of this property of the determinant that you just saw. So here children, we get to see that if we talk about 10, 20, 30, right, and if we talk about 3, 4, 5, and further if we talk about -1, 0, 1, we find that there is something which is similar to all of these three. That is, if you talk about the first column or the second column or the third column, all of these elements are actually in AP, right? For that matter, if say now we talk about the elements of the first column here, you find that the common difference actually is 10. That means to 10, if you add 10, you will get 20, and then to 20, if you add 10 more, you will get 30, right? Now children, if you talk about the next one here, to 3, if you add 1, you will get 4, and then further to 4, if you add 1, you will get 5. So as such, the common difference here is 1. Now if you talk about the third one, we find that here we have -1, 0, and 1, and again here we find that the common difference is again going to be +1, which will be able to get this first term known, then we can find out the second term known, then we can find out the third term by just adding 1. Okay, now how do we simplify this and how will we be able to find out the value of this determinant in a simple way without actually going ahead with the expansion, which is going to be having a lot of calculations? So this is where this property is going to help us, and I'll show you now. So let us see now that we have now this property which is going to get applied. So as such, what we do is, let's talk about now, tell me, is it columns or is it rows on which we're going to do the operation? No, it's not going to be a physical operation involving some biology, right? Nothing of the anatomy we're going to study here. Mathematically, tell me, what operation are we going to do? Are we going to do an operation on rows or on columns? Well, I'll tell you. If say you talk about now operating this, this and this, then what you can do is you can just operate the rows. So let's talk about row 3, which looks to be the largest, and here we operate it by subtracting from the elements of row 3, or rather we can say that the elements of row 3 we can add minus times the sum of row 1, right? And we can also add to it minus times the elements of row 2. And then as we can see, this is going to get pretty much simplified. So in the next step, what we're going to do here is we will now do this. Remember here children, that is that row which undergoes the change, which is on the left hand side of the arrow. So the one which is going to go and have the change is going to be this third row. And what is the change? This actually is the change which is going to happen, right? So this is what you always require to remember as to what will change and how will it change, right? Now we will actually show you how this is going to happen. So let's say now we talk about first bringing up the change, that is bringing up the new elements of row 3. So as you see, this can also be simplified and written as from the elements of row 3 you require to subtract the elements of row 1, and you also require to subtract the elements of row 2, because plus minus is going to become equal to minus for both of these cases. Now as such, here you will have 30, from which is going to be subtracted the element of row 1, which is 10, and also the element of row 2, which is 20, right? Now if you talk about the second column, we now have from 5 we will have subtracted here these elements, that is we will subtract 3 from it, right? And we will also be subtracting here 4, right? That is, this is how it can be simplified. And further now in the last column, what we can do is from the elements of row 3 we have to subtract the elements of row 1 and row 2, that is it will become equal to minus times of minus 1, right? And for then you will also have minus 0, and as 0 is additive identity, so it will not bring up any change. Now here, children, I'm going to show you something special. Just wait for it. So here what are we going to get is, if you talk about the above rows, they will remain to be as it is. So as such, writing it is not that important. Actually, I want to show you something special, so I'll show it now. So let's say now we have the elements of row 1 to be written as it is, and then we have the elements of row 2 which has to be written as it is, as these were not the rows which underwent some change. Now children, here what you'll be getting is, obviously the row 1 and row 2 are going to remain to be the same, and you find that in row 3 the first element is 30 minus 10, which is 20, 20 minus 20, which becomes equal to 0, right? Similarly, if you talk about the second column of the third row, it's going to become 5 minus 3, which is 2, and 2 minus 4 is minus 2, right? So actually it's getting simplified, right? And now if you talk about the last one here, we will have 1 minus minus 1, right, which will become equal to 1 plus 1, that is 2, and obviously as 0 is additive identity, is not going to bring any change. So this is how we can do it, and we actually have been able to simplify this. Obviously the first row is going to be 10, 3 and minus 1, and the second row is going to be 20, then we will have 4, and then we will have 0, right? So obviously these rows, rather the row 3 has been simplified a lot, and moreover in the next step what you can do is you can also take this 2 to be common outside from row 3, right, and it can be pretty much simplified, right? But I'm now going to show you a method by means of which, if you apply a little bit of concept that I gave you earlier, you could have done this in a much more simple way, right? So here what you can do is, first, if you want to do it by this method, then you will go to the next step where you'll be writing 10, 20, and then you also have 0, right? And here children, you have 3, then you have 4, then when you take 2 to be common outside, you'll just be left out with minus 1, and here you'll be having minus 1, 0, and when you take 2 outside, again you'll be getting 1. So it is pretty simple one that you can expand, although as there are 2 zeros which are splattered not in the same row or column, you will have to try and find one more 0, and that is pretty simple. But I'll now show you another method by applying this property. This is going to be very simple, but obviously for that you should have noted one thing, that is the elements are in AP. Now what is the special characteristic when they are in AP? Tell me. The middle term, right, serves as the arithmetic mean between the first and the third, or in other words we can say that we actually have b minus a, the common difference, which becomes equal to c minus b, which is again the common difference, right? And now when we bring b to one side, we get 2b, which becomes equal to a plus c. Now does this equation tell you something, that there's going to be something big which is coming your way? Anything? Yes? No? Well, I'll tell you. Now what you can do is, let's again go ahead with the determinant that we had initially, that is 10, 20, 30, 3, 4, 5 and minus 1, 0, 1. Okay, so now we're going to write this determinant. So here as such, we now have here 10, 20, 30, then we have 3, 4, 5 if I remember correctly, and then we have minus 1, 0 and 1. Quickly checking it out that I've made a mistake or not. Okay, that's perfect. So my memory is good. Okay, now here what you can do is, as we've seen that 2 times of b can be put equal to a plus c. So if somehow we can get somewhere where both the things are equal and we can subtract both of these things, obviously what will be the difference? 0. And if 0 comes in each of these places, then obviously what will happen is our determinant will actually be known to be a 0 determinant, that is, its value will be 0. So let's do this. So in order to do this, can anybody tell me what exactly you require to do as a step? Yes, there are some beaming faces. No? Well, I'll tell you. So what you do is, if suppose you do this step, that is, if say to the elements of R2, or rather to the elements of R1, right? Now you add the elements of R3, right? So here you will then have the elements of R1, right, to be added to the elements of R3, right? Now after doing this, if suppose from it you are now going to subtract the double of the elements of row 2, then you should be able to get to a 0, right? So this is what we're going to do. So first we are going to do this operation, that is, now we will be changing R2 as its twice, right, from which we're going to subtract this. So now we're going to change our R2, right, to be such that from 2 times of R2, right, we are going to subtract this. So I'll rather write this in a cleaner way so that you can understand it better. So here we will now have R2 to be first multiplied with 2. I'll rather do that step first so that you can understand. Remember children, contrary to a matrix where if there was a number which was common to the whole matrix, it could have been taken common outside, here even in a row or in a column, if there's a number which is common, you can take it out, right? So here children, as we are going to multiply the row 2 by 2, so obviously what you can do is you can keep 1 upon 2 to be waiting outside so that both of these cancel each other. So doing this step children, next now what you'll be doing is you will now be having 1 upon 2 waiting outside. However, if you talk about the determinant within, now the second row is going to be multiplied with 2. As such, you will now have here 2 into 20, that is going to become equal to 40. Then you'll have 2 into 4, which will become equal to 8. And further, you will have 2 into 0, which obviously will still remain to be 0. And as this is the only thing which is on the left hand side of arrow, as such, it will remain to be constant. And thus here, if you talk above the first row, that is 10, 3, and minus 1. And then if you talk about this to be 30, 5, and 1, it will remain to be as it is, right? Now next children, what you do here is, if you talk about the next step, I hope you know it. So what are we going to do is, we will now be doing this operation, that is, to the elements of R2. Now you are going to add, or you can directly say subtract, as I've already made you understand that if you talk about subtraction, it is actually 1 where you are adding with minus sign multiplied with something, right? So I already gave you an example. So here what you can do is, from the elements of R2 you can subtract the elements of R1 and R3, right? So what are we getting here? I'm sure you people know that if you talk about the element of R2, you already know that that is 2b, right? And from that, when you are subtracting A and when you're subtracting C, right, obviously this ought to be coming to 0. So next step now, what we do is, we will now go ahead with this, and we still have 1 upon 2 outside. And then further here, we can write this to be now operating on that which is going to change, that is row 2. So it's going to become equal to 40, from which you're going to subtract 10 and you're going to subtract 30, right? So you get a very happy 0. Now if you talk about the second column, now from 8, right, we have to subtract actually 3, the element of the first row, and 5, which is the element of the third row. And again you get to see here that 8 minus 3, that is 5, and 5 minus 5 will again become 0. Again, I'm sure you're feeling very happy, right? Because in determinants we tend to feel very happy when we get in a specific row or in a specific column all zeros. So that shows that no more calculation, just write that to be equal to 0. Now here further, if you talk about the third column here, to the elements of row 2, that is 0 here, you have to subtract the element of row 1, right? And as such, it's going to become equal to minus times of minus 1. And then further here, again, you will be subtracting the element of row 3, which is 1. So as you see, minus minus will become equal to plus. So this will become equal to 1, right? And from 1, you are subtracting 1. As such, this also gives you a 0. Very happy? I'm sure there are some guys who are clapping. I can hear it out. Well, there is still a little more which is to be done. Yeah, it's almost done, because now you already got a 0, right? So 10, 3 minus 1, 30, 5 and 1. On the contrary, when in your examination you get a 0, you feel very sad. But here when you're getting a 0, you are actually feeling to be joyous, victorious, right? Because it has made your determinant to be very simple and you can directly get to the value. So if we talk about the middle row, it will come to 0 as we just calculated. Then we'll have another 0, and then finally we'll have another 0. And if you talk about the first row, it'll be 10, and then it'll be 3, and then it is going to be minus 1. And then here we will have 30, and we'll have 5, and we'll have 1. And children, this is the determinant. As any row or column of a determinant being 0, the value of the determinant is 0. As such, we can write this to be equal to half times of 0, and as if to any number 0 is multiplied, that number actually becomes 0. So as such, the final answer becomes equal to 0, right? So obviously here you require to write that special property that we applied here. That is, we'll be writing, since a determinant which has all elements in a row or column to be 0, has, I'll rather write in block letters, that will give it some importance, has 0 value, right? So now children, I'll just quickly discuss the sum all over, so that if there is something that you missed, then you should also be able to understand that, and nothing ambiguous should be left after the class. Okay, so here children, we had a concept that was regarding a property of determinant that I really want to discuss with you. And before doing that, I actually started off with telling you people that the founder of determinants, in fact the first founder, because the second founder, that is Gottfried Leibniz, is more popular. He is actually the one that you will find all around in different websites, that he is actually known to be the father of determinants as a topic. But actual father is who? The actual father is actually Seiki Takakazu. Okay, he did it in 1683 and Leibniz found it out in 1693. Okay, so here children, we discussed that when we talk about determinants, there are certain properties which can make your life in determinants pretty simple. Otherwise you will have to go the long way. So first we understood what a determinant is. It is actually a collection or an array of numbers, but it is square. That means if you talk about the rows or if you talk about the columns, they are equal in number, and that is why this determinant can be said to be of order 3. It actually has been derived from a matrix. That is, there should have been a matrix of order 3, right? That means which had 3 rows and 3 columns, and we actually have got all the elements, and we've written between these vertical lines which are parallel to each other, which shows that it is actually the determinant of that matrix. Now, in order to find out the value of the, this determinant, right, you require to actually expand. But before expanding, if you can apply some property and you can simplify, then obviously you always try and do that. So here children, what we have is, we have a property that is going to help us a lot, as you just seen. So if to any row or any column of a determinant. So we pick up any row or any column of a determinant in accordance with some property getting applied, like you saw here. We added the equimultiples of some other row or column, right? So to the elements of any row or column, you're going to add equimultiples of some other row or column, as you saw here. That means if you talk about the elements of, say, C2, then you can multiply it with -4 and then add it to the elements of column 1, right? But to every element, you should have multiplied by -4, and that is why you say equimultiples of any other row or column. Then the value of the determinant remains to be unchanged. So if earlier the value came out to be -400, later also it will come out to be -400. So if that's the case, why not apply the property and simplify the determinant? Yeah, that is what we're going to do. So here, children, we have this determinant which requires to be calculated. So what you do is you find out the value of this determinant by applying some property. Now first, any Tom, Dick and Harry property was applied. Rather, this property was applied in a Tom, Dick or Harry way. That means any way, right, without trying to reason much. But obviously that also does give a little bit of simplification, and the teachers who examine your copy do give you marks even for that simplification if that application of property is correct. Moreover, we've got to get to the actual one so that we get the answer in a most easy way, right? So here, children, we have this determinant which is actually 10, 20, 30, 3, 4, 5 and -1, 0, 1. So if you look at it just like this, that 10, 3, -1, 24 and 0 and 35 and 1, probably you won't be able to see much. And that is why whenever you have a determinant, you should actually see it and try and understand which property is to be applied and how, so that you can get to a very simple answer. Now, children, next what we do is we have actually tried out that method which is not going to yield a lot of value. Now, what was that method? We did what? We just subtracted from the elements of R3 the elements of R1 and R2. That is, the operation which was done was to the elements of R3, right? We brought about the change by adding to the elements of R3, that is the row 3, the sum of -1 times the elements of row 1 plus, that is again to it a sum of minus times of the elements of R2. Now fortunately for the first case, it gave us 0, that is 30, from which when you subtract 20 and 10, then you'll be able to get to 0, right? So we feel that this probably is correct. Then when we get ahead to the next one, we get to see that this is actually 5, from which you'll be subtracting 4 and 3, so this will come to -2, right? And then finally, if you talk about the third one, from 1, if you subtract -1, you will get 1, right? And 1 minus 1 is going to make it 0, right? So as such, as there is a subtraction, right, from 1, so minus will make it plus, as such you will get 2, right? Obviously here there is one thing, you can say ray of hope, that is, you can take this 2 to be common outside, and then this determinant looks to be pretty simple, as 2 zeros has already been brought, and now you can actually get to another 0 by simplifying this a little more, because 3 zeros anywhere in the determinant are required to be able to expand a determinant. If you do it before it, then you'll be losing marks. So here, children, next what we do is we actually try and think a little more, and we tend to see that these elements were in AP. That means here, if you talk about this 10, 20, 30, right, or if you talk about this 3, 4, 5, or if you talk about this -1, 0, 1, in the first case the common difference was 10. So to 10 if you add 10, you will get 20. To 20 if you add 10, you will get 30, right? That is, the common difference is 10. Now if to 3 you add 1, you will get 4, and if to 4 you add 1, you will get 5. Similarly, if to -1 you add 1, you will get 0, and again to 0 if you add 1, you will get 1. That is, the common difference is actually 1. So having seen this, we also know that we can write it as the second term minus the first term to be equal to the third term minus the second term, right? This is the basic characteristic of the terms to be in AP, that is common differences are equal whenever we talk about any two consecutive terms. Okay, from this, children, we can gather that if we keep the b to one side, we'll have 2b to be equal to a plus c, or in other words, we also know that b is actually the arithmetic mean between the first and the third numbers, right? So we can use this because here we get to see that both sides have come to be equal. So if we can get to both of these coming over and subtract them, then actually we'll get 0, and because all of these three are in AP, so it will be a 0 in any row, right? And thus we will give it a try. Now before doing it, children, what we do is we actually first double up the elements of row 2, which actually is going to form our B, right? And here I told you that if there is a determinant which is to be multiplied by a specific number, then any row or any column will be multiplied by that number. However, that number also has to be kept outside, because when you multiply it, if you bring it outside, then 2 should get cancelled and you should be able to get to the original determinant. Now next, we have multiplied by 2 and we've kept 1 upon 2 outside, so the elements of row 2 will now become 20 into 2, that is 40, 4 into 2, that is 8, and lastly we have 0 into 2, which is 0. Next, now what we do is, to the elements of R2, the operation is done, that is R2 minus the elements of R1 minus the elements of R3. So that then is going to become equal to 2b, which we've already done, right? And from that we're going to subtract a and c, and as we know that both of these are actually equal, that is 2b and a plus c are equal, so we can say that 2b minus a minus c is going to yield a 0, and that is what actually we get. So here when we do this operation, here what we've done is we now subtract from 40 10 and 30, which makes it 0. Then from 8 we subtract 3 and 5, which again makes it 0, and then from 0 we subtract minus 1, which makes it 1, and then 1, so it becomes 1 minus 1, that is again 0. So here in the second row we have got all the elements to be 0, so we have this property: a determinant which has all elements in a row or column to be 0 has 0 value. As such, we very simply and very happily write half, which is already outside, into 0, which is now the value of the determinant, and we get to 0, which becomes the final answer. This, children, is the astute way or the intelligent way of doing it, although if you do it by the above method, right, or you apply any other, permutation and combination of, you try out with the columns, right, if you're doing some simplification, you can expect that some marks can be given by the examiner to you for the steps. However, this is the best method that you can follow, and then you can get to 0, right? And as getting to 0 is something that the teacher would like to see, that if you've been able to bring it or not. So obviously there can be some special marks which can be awarded for this step, right? And thus doing it this way will accord you full marks. So have you all been able to understand this property? Did you like this example that I gave you so that you can understand this property? Well, if you really liked it, then you should give me a like, because I, at the end of this lecture, I'm waiting for all of this, right? I fish for compliments, because these compliments are the one which actually push me to be making good videos for you people. Moreover, what is that special thing that you liked in this video? Do write it, right? Share it to your friends so that everybody gets to know about this rule, and also tell a little about Siki Taka Kazu, right? And what the special thing that we've got to know about determinants, and that thing should spread around like a rumor. Moreover, if you have some doubts, you can write it in comments, or there is a Google form which is waiting for you in the description, right? Make sure you write your problem in it and send it to me, and when I get it, I'm going to get to a one-on-one consultation as to how I can get you rid of the problem that you have. Right? Now, children, this can really fast track your journey to be able to get to that magic number. You know what that magic number is? I'm sure everybody knows, right? Yeah. If you talk about this magic number, the magic number is actually 1 0, and there's another 0, that is 1 0 0. So you get 100 out of 100, or in other words, you can say 100% marks, which is what you really require. And to be able to fast track that, what you can do is you can just fill up that form and you will get help. Moreover, there's another shot, right? And the link to which has been provided to you. So that quickly tells you about this rule, right? And here, when you see the shots, they're actually made in such a way so that if you look at the shots just before your examination, it'll serve as a good tool for revision. So children, this is Saurabh Kumar Dutt signing off from the Mathematics Helpline, which is bound to be helping you people in mathematics and make you really comfortable in this subject. Bye. Have a nice time.